So now that you know a bit more about what a factor method is in the context of completable futures, let's take a look at how you can apply factor methods in practice. And we're going to do this again, as is our tradition, with the big fraction multiplication example. Not because that's necessarily the most profound example of completable futures. It's just a nice way to kind of go back and compare each of the different approaches in a nice kind of apples to apples way, because they're always doing the same computation, either by using a good old Java future or the basic features of completable future or the more advanced features of completable future. And you can see at a glance how the different features add new capabilities and are a benefit and an improvement over what came before. Once again, this example is available in my EX8 folder. So what we're going to do here is we're going to use supply async rather than using an explicit creation of a new thread, which is what we had done earlier. And what supply async does is it arranges to execute the given supplier lambda in the common fork join pool, or at least this variant of supply async will do that. We're not using the 2-parameter version. We're using the 1-parameter version, which uses the common fork join pool by default. So we give it a lambda expression, and this supplier lambda expression, once again, will multiply two big fractions. And as you see at the bottom, it returns the result of that multiplication. So we're no longer completing something. We're not making an incomplete future, completable future that then we have to complete explicitly. We're just using the supply async factor method. That computation is defined with the supplier lambda, and anything that occurs after the call to supply async and up to the join will run concurrently. So that's similar to what we had before, but notice there's no explicit threading required here. As with the previous example, we're still limiting ourselves to kind of the basic synchronization capabilities and barrier synchronizers. So we're just going to use completable future join method. And notice how this particular example does not require any explicit threading. And it also requires no explicit synchronizers for that matter. So that's a nice simplification over what we had to do before, where we had to spawn a thread and start it explicitly. Because it's coming out of the common fork join pool, moreover, it doesn't typically take as long to start the computation running because we don't have to create the thread on demand. That thread most likely has already been created in the common fork join pool, and so we're just going to tap into what's there. Likewise, another thing that's better than the version we looked at before is we don't have to explicitly complete the future, since supply async returns a completable future. So as a result, we also don't have to worry about forgetting to initialize the future, whereas with the earlier approach where we created an incomplete completable future, we had to remember to initialize that, which is clearly tedious and error prone. However, we still have a problem. Of course, there's always a problem. And that is we're still calling join explicitly. So I will fix that problem with other discussions of other completion stage methods as we get to that momentarily. So that's the end of our overview of how to apply factor methods in practice. We're almost at the end of our discussion of completable future factor methods, but there's still one more thing I want to cover before we're done with this section.